Hello friends, welcome back to Tech Byte series, software testing concepts for the beginners. In this session, we are going to learn about the different types of testing techniques, which are nothing but the testing methods. So usually, what is a testing technique or a testing method? So it is a kind of technique where identifying different types of test data to test the same functionality repeatedly and making sure the requirement has been developed as it is supposed to perform, as it is expected by the end user. So this is called the testing method or a testing technique. So in general, we have three types of testing methods. One is the equivalence partitioning, the second one is boundary value analysis, and the third one is error guessing. Equivalence partitioning. So what is equivalence partitioning? Equivalence partitioning is a testing technique where we have to partition or identify that equal sets or equal partitions of the data based on the requirement or the functionality and testing the same with the data which is identified. When it comes to the boundary value analysis, it is a different type of technique, identifying the test data based on the boundary conditions of the requirement or the functionality being tested, and then after identifying the data with the similar whatever the functionality and what are the boundary value conditions, then executing the same test repeatedly with the different types of data identified. This is called boundary value analysis. And the last one is error guessing. So this is a special kind of technique where user can identify some test data based on the previous experience with the similar kind of requirement or the similar kind of functionality which was tested in the past, and thinking the application might fail, the application might result in error with a special kind of data, and taking that data and testing the application and making sure whether the application works with the same data. So this is called error guessing. Now let's try to understand a little bit in detail about the equivalence partitioning. As we said, in the equivalence partitioning, we have to identify sets of data with the different partitions and testing the application with with that kind of data. Let's take a sample requirement. XYZ bank login page must accept alphanumeric characters. What it means, when user creates his username or when user tries to log in, so the user can give either alphabets or the numerics or combination of the alphanumerics. So this is what the requirement is. So how we partition the data is, the first set is only alphabets, and second test is just the numerics, and the third set is both alphanumeric combination. This way, with just providing the alphabets, we have to test and making sure the application works as expected, and repeating the same test with the numeric data and making sure the application works as it is supposed to be. And the third time we repeat the same test again with the combination of alphanumerics. So this is called the equivalence partitioning. And the next test method is boundary value analysis. As we discussed, we identify the boundary values based on the requirements. Let's take an example, sample requirement. XYZ bank username must be minimum 6 characters and maximum 12 characters. What it means is, when the user creates the username, the user must give at least 6 characters. If not, system should not allow to create the username. At the same time, user can enter at most of 12 characters only. If the user tries to give more than 12 characters, system should not allow to create the username. So here we have two boundary conditions. One is the lower boundary condition, which is minimum 6 characters, and the upper boundary condition is maximum 12 characters. That's the way how we identified the test data is testing with 5 characters where system should not allow to create the username, and 6 characters and 7 characters, yes, system can allow to create the username. And when it comes to the upper boundary value, 11 characters and 12 characters, system should allow to create the username, whereas when we give the 13 characters, system should not allow to create the username. So this is the boundary value condition, boundary value analysis testing. And the last one, as we said, error guessing. Let us take a sample requirement. Assume there is no specific requirement for the XYZ bank mentioning, hey, system should time out when the user is inactive for a long time. Say for example, the user provided username and password. Now the user is on the home page of the bank application, or else the user is on some transaction page, but the user is idle for half hour or 1 hour without doing any action. In this case, in general, any software application will get the timeout, just making sure from a security perspective there won't be any suspicious activities will be happening because the user is inactive. But there is no such kind of similar requirement provided as part of the requirements for this XYZ bank. But the user or the tester, whoever is testing this application, has a past experience testing similar application for a different bank, and that user has observed what was happening at that time if the user is idle for some time. So keeping that into consideration with the experience, identifying some test data, how the user behaves, how the user is inactive, and testing that condition and see what happens in this XYZ bank application. So this is called the error guessing. And now let's see the testing life cycle. As we discussed software development life cycle in our beginning previous session, testing also has a life cycle. So what that means is, so the testing life cycle is a sequence of phases or the activities performed as part of the software testing. That means when we say software testing, it's not just a single activity. It has multiple activities. So all those activities in the sequence of order is called the life cycle. So let's look at the software life cycle, testing life cycle, what we have. It starts with the requirement analysis. What it means, when a software requirements are provided by the end user or customer, both the developers as well as the testers will be analyzing the requirements to understand what is supposed to be, what the application is supposed to be built, and what the customer is expecting. So this is the requirements analysis phase. And then the test planning phase. In this test planning phase, we'll identify what are all the different types of test activities has to be done, how it has to be done, and all those things. So at this time, we are not going in detail about the test planning. We'll go in our further sessions, in the upcoming sessions, but let's try to understand at a high level what it is. And the next phase is test case development. So once the test planning is done, the testing people will develop the test cases to test what the functionality is, what the requirement is about, what the customer is expecting out of the requirement. So this is called the test case development phase. And then the test execution phase. In the test execution phase, the test cases whatever has been developed will get executed against the software application which is developed by the developer. So this is called the test execution phase. And the last phase is test closure phase. In the test closure phase, all the artifacts will be documented, all the test results will be documented, and everything will be shared with the business liaison or the customer. And this phase is called the test closure phase, and this is the last phase of the testing life cycle. With this information, we will conclude today's session, and in the upcoming sessions, we'll learn more about the testing and all the different concepts of the testing. And thank you for watching the video, friends. If you like the video, please comment, share, and provide your feedback.